tab here. This is a video on technical mathematics. There are several in a series that you may view. This particular video is on equations with radicals. At any time you can stop or pause the video to examine the material with more depth. Let's get started. First of all, we want to talk about a radical equation. We're going to be working with equations now. So a radical equation looks something like this. A squared equals 5. Okay. So it has an equal sign on it, and you are to solve for a. So we're going to be looking at equations. Now, extraneous roots. These are roots of a new equation that are not roots of the original equation. So after we get an answer and solve this for a, we have to go back in and put that answer in for this equation, our original equation, and see if it's actually true or not. If they come out not true, they are referred to as extraneous roots. Alright, let's get started on problems, and I think we'll explain what that means. Okay, let's get this started. Alright, in order to solve this equation, first of all we have to get rid of the radical sign. And we can do that by squaring this. That gets rid of the radical sign. However, we have to square both sides. As long as we do the same thing to both sides of the equation, we're not changing it. So then what we have is x minus 16 equals 25. That makes it much easier. So therefore x, when we add 16 to the other side, x equals 41. Now let's check for those extraneous roots. Let's put it back into the equation. 41 minus 16 equals 5. 41 minus 16 equals the square root of 25. And yes, the square root of 25 is 5. So that is a good answer. We don't have any extraneous roots. That's a true root. But let's look at the next one. Here we have x squared minus 75 equals x plus 5. And again, we are going to square both sides to get rid of this radical. Okay, so then we end up with, no, if that's not true, I'm sorry. We get rid of the radical, right? That's the whole purpose. Okay, so we got rid of that radical. So this side becomes x squared minus 75. Now, in previous videos, I show you how to quickly, what you may be used to as FOIL, I use what I call the smiley method. Here's the first smile, that's 5x. The second smile is 5x. I add that down and I get 10x. That is my middle term of my trinomial. The first term's x times x is x squared. And the last term's 5 times 5 equals 25. I'm sorry, plus 25. So that side would become x squared plus 10x plus 25. So to square this side, Since it was a binomial squared, it actually came out as a trinomial. So let's simplify. We've got x squared and x squared here. Okay, let's subtract 25 from both sides. So we have negative 100 equals 10x. So x equals negative 10. Okay, let's keep track of that. That's our answers. Now remember, we still have to put it back in the original equation. So let's put it back in. Here. All right, tell you what. Let's put it back in the original equation. That's what we said we were going to do. So the square root negative 10 squared minus 75 equals negative 10 plus 5. Okay, we can simplify that. That's 100 minus 75, so we've got the square root of 25 equals negative 10 plus 5 is negative 5. So the square root of 25 is 5 equals negative 5. That's not true. Therefore, this answer is also not true. And this is what we call the extraneous root. Let me get this in here. So we thought it was the answer, but when we put it back into the original equation, it turned out false. Therefore, it's an extraneous root. So now you see how that works. So we've had one with a real root, and we've had one with an extraneous root. You just never know until you go back and check them. Here's one for you. Try this. Stop the video and try this. Now I want to give you one tip. This minus 18 can't stay on this side of the equation. So the first thing you want to do is move this 18 over here. And then square both sides and solve. Don't forget to check your answer to see whether it's a real root or an extraneous root. Okay, we're getting a little more complicated here. Y over 3 plus 4 raised to the 1/3 and 5 halves. Now what can we do? We still do the same thing we did before, only we're going to take this whole thing and raise it to the third. And we're going to take this whole thing and raise it to the third. 1/3 power raised to the third is 1. So we end up with y over 3 plus 4 equals, let's see, 5 cubed is 125 over 8. All right, here comes your math skills. We have to subtract 4, but we have to make 4 equals how many eighths? 4 equals 32 eighths, doesn't it? So we have y over 3 equals 125 eighths minus 32 eighths. Okay, so you had to put that in terms of eighths so that we could subtract it. So now we have a simpler equation, y over 3 equals 93 eighths to get rid of the denominator we multiply, So let's see, 3 times 93 is going to be about 279 over 8. That is the answer. Now you would go back in and you'd put that answer, you could put that into a decimal point, a decimal equivalent, and put that back into y and run through the entire equation to see whether it's a real root or an extraneous root. I'm going to go on so that we can go through some more problems and not really go through the checking portion of it. Okay, here we have x plus 1 raised to the 3/4 and 8. All right, again, we're going to do the same thing. Pen. We want to get rid of that 3/4, so what do we multiply it by? 4/3. And the same thing with 8. We multiply that by 4/3. Okay, that becomes x plus 1. That simplified out very nice. But what is 8 raised to the 4/3? You can put that into your calculator and you'll see that x plus 1, 8 raised to the 4/3 would be 16. Therefore, x equals 15. Okay. For those of you that don't know how to put this in your calculator, you should put in the number 8, and then you should see a caret, and you put in 4 divided by 3. And that should give you an answer of 16. All right. Hopefully you have the calculator that has the caret key. All right, good. Again, go back in and put it in the original equation. All right, here comes a tricky one. Now, it doesn't look too bad. What if we square both sides? What happens? That doesn't seem too bad to get rid of that, right? And this side we square. So we ended up with x squared minus 4 equals 2x minus 1. We combine like terms and we get x squared minus 2x. We'll write them in the decreasing order. Minus 3 equals 0. Therefore, we can factor this, x minus 3 and x plus 1. If you don't remember how to factor, please return to the factoring video. Okay, so this gives us x equals 3. Remember, we set x minus 3 equal to 0, giving us 3. And this x equal to minus 1. Now, we've got two roots. Is it possible that both of them will work? Maybe not. This time, I'm going to run through the check with you. So, let's see. Let's start out with our radical. And we've got 3 squared minus 4 equals the square root of 2 times 3 minus 1. So I'm just putting that all in there. So we get the square root of 9 minus 4, which would be radical 5, and 6 minus 1 would also be radical 5. So that's good. So 3 is a good root. Let's see if negative 1 is. Negative 1 squared minus 4 equals 2 times negative 1 minus 1. Negative 1 squared is 1 minus 4 gives us the radical negative 3 . 2 times negative 1 is negative 2 minus 1 is negative 3. Okay, now these look to be correct, right? But both of them are non-real numbers. A negative sign underneath the radical would bring this out as a non-real number. Actually, it would bring it out as the square root of 3j. And what we're looking for in our original equation is real numbers. So this can come out as a real number. Once we put that negative sign in there, it's no longer a real number. So only this one is the answer. This one, negative 1, is an extraneous root. All right, very good. That's the end of this video. Hope you enjoyed it.